How's it going, awesome college algebra students? So today we're just going to go through the end of the factoring section, and then we will play a little bit of factoring tic-tac-toe. Now the first thing that I want to go over is how to find the difference of two squares. So here we're going to take our squares and we're going to separate them with a positive and a negative binomial. So in this first example, we have x squared minus 81. Well, this can be written as x squared minus 9 squared. So we do have two square numbers. So we can just rewrite this as x plus 9 and x minus 9. All right, if you take a look at the next one, we have 36x squared 25. This, too, is just a couple of squares. 36 is 6 squared. X squared is obviously x squared. And 25 is 5 squared. So we can rewrite this as 6x plus 5 and 6x minus 5. All right. Now, down here, the same thing. Even though we have x to the fourth power, which is really just x squared twice, right? And 81 is 9 squared. So we can write this one as x squared plus 9, and then x squared minus 9. However, here, again, we have a difference of squares, because x squared minus 9 is the same thing as saying x squared minus 3 squared. So I can factor this one even further, right? We can make it x plus 3 and x minus 3. So this first one, we got to bring it down, and that is how we get our solution. All right, let's take a look at this next one. All right, here we have a difference of squares because 81 is 9 squared. And x to the fourth is basically x squared squared. And 16, which is 4 squared. So when I factor this out, that'll give me 9x squared minus 4, or plus 4. Let's do the positive first. And then last we have 9x squared minus 4. Now again, this second binomial is a difference of squares. 9 is 3 times 3, x squared is x times x, and 4 is 2 times 2. So I'm going to bring this 9x squared plus 4 down. Nothing I can do there. But this one I can do another difference of squares. I can say 3x minus 2 and 3x plus 2. All right. Next, I want to go over factoring the sum of cubes and difference of cubes. So for the sum of cubes and the difference of cubes, we really just have this formula that we have to do. If we have a cubed plus b cubed, we're going to separate that into a binomial that'll be just a plus b, and then a trinomial, which is a squared minus ab plus b squared. If we have a difference of cubes, it's the same format. The only difference is going to be that sign. If we have a difference of cubes, that first sign is going to be negative, and this, all right, and in the trinomial, the first sign is going to be positive. Where when we have the sum of cubes, the first binomial is positive, and the first sign in the trinomial is going to be negative. Now, if I have the expression x plus 3 plus 8, well, that's really just x cubed plus 2 cubed. So if I wanted to rewrite that using the expanded formula, I can just say a plus b, which would be x plus 2. And then the trinomial would be my a squared, which is my x squared, minus ab. ab is both terms, so it's x and 2, or just 2x. And then last will be the b squared, which is 2 squared, which would be 4. All right, so using this template, that was the word I was looking for, that is how we factor out the difference of, or the sum of cubes. Now, in this first example, down here, we have a sum of cubes, and then we have a difference of cubes. All right, so we need to pay attention which template we're going to use. So for this first one, we're going to use this first template. So here we have our a plus b, or a plus b. And then we have our a squared minus ab, which would be minus 1x, or just x. And then last is my b squared, 1 squared, which is just 1. Whoops, it's got to be a positive. There you go. All right, now taking a look at this difference of cubes. Now here I'm going to rewrite that with my cubes. Now 125. 125 is 5 times 5 times 5, which is 5 squared. Sorry, not 5 squared, 5 cubed. X cubed is x cubed, and 8 is the same thing as saying 2 cubed. This is going to help me out with my a and my b. So let's take a look at this. For that first part, the a minus b, all right, it's going to be 5x minus 2. And then it'll be my a squared. Well, 5 squared is 25, and x squared is x squared, plus ab, 5x times 2, which is 10x. And then lastly, it'll be my b squared, so it'll be 2 squared, which is 4. So difference of squares, we just kind of have to use this template. All right. Now down here, we have a few factoring examples. Whenever we have 4 terms, all right, we're going to factor it by grouping. So we're going to group those 2 terms, and next we're going to group those terms. Now, in this first binomial, we don't have a GCF to take out, but this is a difference of squares. So I can say x plus 5a, and this will be then x minus 5a. In the second binomial, I don't have a difference of squares, but maybe I can factor out an 8. So if I factor out an 8, what I'd be left with is x plus 2 with an 8 on the outside. And that is how we do it. Now let's take a look down here. Okay, so again, if I factor this by grouping, all right, I definitely have a difference of squares here, and it looks like I can factor out the greatest common factor there. So if I use difference of squares, I will have x plus 6a and x minus 6a. And then from the second binomial, I can take out a greatest common factor of 20. And I'd be left with x plus, and then 100 divided by 20 is 5. So that is how I factor by grouping. All right, here it wants me to do 2 things. It wants me to write an expression for the area of the shaded region, and then it wants me to factor that out. So to find the area of the shaded region, I'm going to first find the area of everything. Then I'm going to subtract out the 4 white spots, and that'll give me the area of everything. So first, to find the area of everything, I'm going to do 3x times 3x. And then I'm going to subtract those white spots. Well, the white spots, it looks like they are 4 rectangles, or 4 squares, where I need to do 2 times 2. All right, so if I multiply the 3x times 3x, that'll give me 9x squared minus 2 times 2 is 4, times 4 is 16. So that is the expression of the shaded region. All right, now for b, I need to take that expression and I need to factor it. So, I have 2 terms. Looks like I have difference of squares. So I can say, 9 is going to be 3x, and 16 would be 4. And then I have 3x minus 4. And I'm looking to see if I can factor it further. I cannot, so that is my answer in factored form. Taking a look down here at this one here, again, I want to multiply the base times the height to get the area. And then when I do that, I'm going to subtract out the rectangle in the middle, so I'm left with the area of the shaded region. So the base is x, the height is y plus x, or x plus y. So I need to multiply x times x plus y. And then I'm going to subtract the area here, which has a base of y and a height of x plus y. So then, to simplify this, x times x is x squared, and x times y is xy. All right, and then here, negative y times x is negative xy. And then negative y times positive y is negative y squared. And here, I can even simplify this. So then here I have x squared minus y squared. And that is the polynomial. Now, to put it into factored form, here again, I have a difference of squares. So I can say x plus y and x minus y would it be in factored form. Okay, so that is the last section on factoring. If on your own you want to go back and do this one, all right, this would be great practice. This is a difficult trinomial one, but then that should take us to the end of this section. Please work on the tic-tac-toe factoring with a partner, and then you can start your homework.